Welcome to Group 17's wing design video. We will take you through our design process. For the design of our wing, we used the 4 stages of design consisting of conceptual, preliminary and detailed designs until we came to an accepted final design. We found these different designs through theory and practical experiments that we will now explain. To start our conceptual design, we drew them by hand to visualize what we needed to make. We drew the spar and the ribs as well as the cross-sectional designs. To begin more accurate designs, we used Excel to predict the performance of different dimensions of the wing. This was so that we could find the optimal measurements for each factor for the material properties given, such as the Young's modulus. The Excel program we used showed us whether our design passed or failed the bending moment and tension requirements. We used it to find the optimal width and height is 50 millimeters and the optimal length of the rib is 300 millimeters. To have a more detailed illustration of the wing, we used SolidWorks to assemble the different components together and subjected it to stress tests. These were far more in-depth than the Excel, as the fine mesh we used solved the stresses and showed the distribution throughout the beam. The highest stress was at the root. One thing to note about our tests is that von Mises stresses were used, which only showed the stress magnitude and not the nature, i.e. tension or compression. Therefore, there was some interpretation of results, but our real-world testing revealed that the foam spar failed first in compression. From the simulations, we used the results to design and conduct real-world tests to confirm our results. These included direct stress and torsional compliance evaluations. We found in the torsion testing that the diagonal cross-section we had did not support the structure enough, so we changed to a different cross-section design. We also experimented with tapering the spar, but in the bending test, we found that tapering would greatly reduce the tensile stress as it would bend much more with less mass added. We found that tapering the spar would decrease the build quality of the final wing, so we decided not to use a taper in the final design. We used these results to come to a final design, which we then built. As you can see, the finished wing design is on the right. In conclusion, we furthered our skills with Excel and SolidWorks. We learned how theory learnt previously translates into real-world applications. We learned how simulations and real-world results differ, but both helped us to get to this final design.